Very good morning, students. For this lecturing video session, I am going to solve a problem from projections of solids. Let me just read out the question first and make you understand what kind of problem it is and what are the data are given and how the projection needs to be drawn. Fine. Right. A pentagonal pyramid of base side 30 mm and altitude 68 mm is suspended freely from a string attached to one corner of the base of the pyramid. The axis of the pyramid is parallel to VP. Draw its projections. Right. So, given data. Here the object is a pentagonal pyramid. Object is a pentagonal pyramid. Pentagonal pyramid. Of side 30 mm. So, S is equal to 30 mm. Right. And altitude. What do you mean by altitude? Altitude is nothing but the height. That is axis height or axis length or long axis, the length of the axis. Right. So, axis height is 68 mm. Is freely suspended from a string attached to one of the corner. Here the object is not resting. Here it is freely suspended with one of the corner. Freely suspended. It is freely suspended with one of the corner. Right. So, here in this problem there is no axis inclination, isn't it? So, this is a special conditional problem. So, in the previous problem I taught you that the diagonal was kept vertical, isn't it? So, in that problem also there was no axis inclination, it was special condition. Similarly, for this problem also, the axis is not being inclined, the axis inclination is not given, in place of which it is mentioned that one of the corner is freely suspended from a string. Right. So, the object could be, assume a string is being tied on one of the corner in this manner. It is being hanging, that is attached through a string. This is how it's freely suspended with one of the corner. Right. So, how this can be? So, where you have to draw the first diagram, that is the two shape. So, in order to lift this, so how the object to be positioned? The object should be positioned in this manner by base resting on HP. So, then one of the corner will have to just hang it over here by using string. Got it? So, if you keep it on the VP, it won't be possible, isn't it? So, by keeping it on HP with one of the corner on the right hand side, with this the string, by using string, this particular object is being freely suspended. This is the final position. So, initial position should be resting on HP, corner is resting on the right hand side. Right. When the corner is resting on, the corner is on the right hand side and resting on base or with base on HP, where you will get the true shape. Looking at from the front or looking from the top. I could see the true shape when I look at from the top. So, the first diagram should be drawn on HP as far as freely suspended problem is concerned. Right. So, irrespective of whatever it may be the object could be, as far as freely suspended is concerned, the resting could be the initial for the first diagram, that is a simple position could be, first diagram should be on HP always. So, do not confuse yourself. So, for this, in order to make this object hanging, with freely suspended, the center of gravity, you'll have to find the center of gravity. The center of gravity should kept vertical with HP. So there is a formula for it. There is a formula for center of gravity. Center of gravity. Center of gravity. Gravity. Ty. So in short, it can be mentioned as CG. In short, CG, center of gravity. For prism and cylinder, the CG could be 1/2 into axis height. 1/2 into axis height. For pyramid and cone, C-O-N-E, cone. The center of gravity formula is 1/4 of the axis height. 1/4 of axis height. So remember this. So as far as center of gravity for prism and cylinder, where you have the uniform shape and size for the top face and bottom face, the formula could be 1/2 of axis height. The pyramid and cone, where you have the vertex or apex, there the formula is 1/4 of the axis height. Remember this, right? And as far as freely suspended problem is concerned, first drawing the true shape always visible on, that need to be drawn only on HP. Then only with that particular corner that can be hung by using the string, right? First let me draw a line representing the XY, that is reference line. Above reference line is VP, below is HP. So this needs to be divided into two. Stage 1 is for symbol position or symbol resting. Symbol position or symbol resting. And stage 2 for, this is for axis inclination or any special condition. As far as this problem is concerned, there is no axis inclination. That's why it comes under special condition. Right? Fine. So what did I tell you? Where to start the diagram? Where to capture the true shape? As being freely suspended, the first drawing should always be on the HP. So here the object is a pentagonal pyramid of side 30 mm. How it is been hung? Corner. So corner should come on the right hand side. So first draw a line of side 30, right? As being pentagon, it has 5 sides, isn't it? So how this can be drawn? Keep your protractor in this manner. Take 108 degree, 108 degree, right? So this could be 90, somewhere like this. So draw a extension line. Similarly, keep your protractor in this position. This could be 90 and 108 degree. Draw a extension line. Now take 30 mm in your compass, keeping at this point, cut an arc. Similarly, keeping at this point, cut an arc on the extension line. Now without changing the radius of 30, keeping at the intersection point, cut an arc here. Similarly, keeping at the intersection point, cut an arc. So there is a intersection. So now you connect it. Connect it. Now erase it off the unwanted lines which may confuse you, right? So this is the object. Now look at the object. Here the corner is on the right hand side. It is freely suspended with the corner. So the corner is on the right hand side. So now I am going to draw the object lines by using H or HB pencil. When you look at from the top, all the 5 sides would be visible. In addition to that, the apex or vertex would be visible when you look at from the top, and the longer, the slant edges would be visible. So for which we'll have to find the center of this, that is the axis, how that can be drawn. So there is a corner, opposite edge or the side, make the center point, mark it and draw a line. Draw a line. Similarly, I am going to choose this corner, opposite of this side, make it midpoint off of it. Now connect it. So this is the axis. Now connect all the corners. Connect all the corners. What about this point? All the slanting edges are meeting at one point is nothing but the apex or the vertex, which can be named as O. Let me just give the naming for all the corners A, B, C, D and E. This is the top view. What about the front view? Allow to project it vertically. Project it vertically. This is the axis, and B and D lies on the same point. Extend it. Extend it. Here the axis height is 68 mm. Where is the axis? This is the axis line. So from here, that is reference line, take 68 mm, cut an arc. So now close it. So this is the boundary. Right. Here, when you look at from the front, it won't look like a rectangle. Right. It will look like a triangle. Right. So from the axis 68 mm, now close that boundary. Close that boundary. Got it? So now the base. Now look at from here. What are the points who are visible? A is visible, B is visible, C is visible. Right? When you look at from here, this BO, that longer edge would be visible. BO, the longer edge would be visible. Right. So this could be O dash. A, B, C are visible. So this would A dash, B dash and C dash. What about D? D is right behind B. Therefore D is invisible. D dash is invisible. What about E? E is right behind A. Therefore E is invisible. And this is the axis. So axis needs to be mentioned long line dot, long line dot, long line dot and long line. So this is the top view and this is the front view. This is a simple position when the object is resting on HP with one of the corner. Now with the help of the string, this object is going to be freely suspended. Freely suspended in this manner. Therefore, this diagram won't rest on the XY line. It won't touch the XY line. Though the simple position drawing, that is the front view touching on the XY line here, because it's going to be freely suspended. It's just hanging in the air. So it won't touch the XY line. So how this can be drawn? So for this, I have mentioned the CG formula, that is a center of gravity formula. So as far as pyramid is concerned, CG is equal to 1/4 of the axis height. What about the axis height here? Axis height is 68. So 1/4 of 68 is 17 mm. 17 mm. So now from the base, take 17 mm on the axis. From the base, take 17 mm somewhere here. This is nothing but the CG. This is nothing but the CG. 17 mm from the reference line 17 mm from the reference line. right? So 17 from the base, take 17 mm on the XY line, mark 17 mm on the XY line. So now draw a line connecting the corner. So this portion, this triangular portion, that is CG, C dash CG should kept vertical. That means perpendicular to the HP. This particular drawing should be kept vertical, right? This should be kept vertical in this manner. So this is CG. This C would be somewhere here. Sorry. If it goes in this manner, this would be C and this is CG. This portion, if I lift it in this manner, right? This is how it is resting. If I lift this one, C point would be on the top and CG would be on the center line, right? This portion, if I lift it in this manner, that is this corner, holding the corner and lift it in this manner, C will come on the top, CG will be here and this would be the base, and this is how it's going to be. So just listen carefully how this needs to be drawn for the special condition problem. So now choose a point, draw a perpendicular line, that is 90 degree to the XY, 90 degree line, XY. Now measure the distance between C and CG. Measure the distance from C dash to CG, keeping this as C1 dash. Cut an arc on this. This could be my CG, this could be CG. Right. So this C and CG has been kept vertical. This triangle needs to be drawn. Now measure it from C to this center line. C to center line, cut an arc. Something like this. Now this base to this CG. From CG to center, just cut an arc. Right? Cut an arc. Now draw line from C to this intersection point. Then intersection point. Got it? So this is nothing but the base. So measure it from C to A. C to A, cut an arc. This is nothing but A1 dash. Got it? Now, we know the height of this one. What? CG. That is 68 mm. Right? And now what I am going to do is measuring the distance from C to O in a compass. Keeping at C, cut an arc here. Cut an arc here. Right? And measuring from A to O, keeping at A, cut an arc somewhere like this. Something like this. Cut an arc, and from here I am going to cut an arc in this manner. Right? Now I am going to connect this. Right? So I am going to connect like this. Now this line passing through the CG. This intersection point is here. So CG is somewhere here. So center line passing through the CG. Something like this. Now measure it from C to B. C to B, cut an arc. This could be B1 dash and D1 dash. Connect the apex. Connect the apex. So this could be O1 dash. Right. So C, A, B, C, D has been captured. A, B, C, D, and E is here. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, and the apex point. So this needs to be darkened. This base. Got it? So as far as this drawing is concerned, with the corner it needs to be freely suspended. This is how it's hung. So the CG and C point should kept vertical. That means C and CG should kept vertical. So for which you have to draw a perpendicular line from the reference line, then mark the C and CG distance on the 90-degree line. Then you have to take C to this base, that is the center line from C, cut an arc. From CG to the base, from C to cut an arc, you will get the intersection point. If you connect from C, you will get the base line. Then measure it from C to O, cut an arc. Then A to O, from A to O, cut an arc, you will get the apex. Is it clear? Now I need to draw the final top view for this drawing, for this object. So project all the lines vertically downwards. This is nothing but the projectors. And from the top view, draw horizontal projectors. Horizontal projectors. Now I got a box over here. I am going to do the mapping work or graphing work here. So I need to see the intersection points, that is the meeting points of each points, that is A to A and A. A is here, this A1. B and B are meeting here, this could be B1. C and C are meeting here, this could be C1. And D and D are meeting here, this could be D1. E and E are meeting here, therefore this could be E1. What about the apex O? O and O are merging here, therefore this could be O1. This is C. Right. So what did I tell you? How to draw the final view. First, boundary should be closed. So boundary is nothing but E to D, D to O, O to B, B to A and A to E needs to be closed. So now I am just closing it. So boundary has been closed now. What is next? Checklist. Checklist for the base. For the base, it is A to B, B to C, C to D, D to E and A. It flows in this manner. Right. Then for the slant edges. What are they? A to O, B to O, C to O, D to O and E to O. These are slant edges or slanting edges, right? So first, when the object is being tilted in this position, that is it is hung in this manner, right? It is hung in this manner. Now the axis is, look at here, the axis is inclined with HP. Therefore, this entire view would be visible. The entire face of pentagon would be visible, right? So for which, what I have to do? I have to connect all the lines. So D to E and yes. So the base, bottom base, I have completed it. Next, slant edges. Slant edges, look at here. What are the things would be visible when you just hang it like this? So this is a C point, right? CO would be visible. CO would be visible. BO would be visible. DO would be visible, right? So this is C point. With that only, it has been hung. Look at here. It has been hung. So CO, BO and DO are visible. CO, BO and what thing is visible. What about EO and AO, which are invisible, right? Because look at here, this point, the bottommost point where and all it is connected, those are invisible. That is, look at here, AO and EO are invisible, right? So AO has been captured, So I need to capture it by dotted line, right? So draw dotted line AO because it is invisible. BO it's already been covered in boundary. CO has already been completed. DO has already been covered in the boundary. What about EO? EO is invisible, isn't it? So which can be mentioned with dotted line. Right. So for that reason only I am just mentioning the checklist. So for the exam point of view, you need not to write anything on the answer sheet. So if you want, you just do the rough work. In the rough work page, you just mention even or write it down with pencil, right? So in the answer sheet, you need not to write it. This is for your understanding only. And in fact, the position 1 and position 2, or that means the stage 1, stage 0 also, you need not to write it on the answer sheet. This is for your understanding only. I am just mentioning it over here, right? So with this, I have completed all the 4 views. So when the object is freely suspended, first drawing should be drawn on HP, because assuming that object is resting on HP with one of the corner. Got it? So now I have to do the dimensioning work here. So that dimension, that is the side or edge of the pentagon, which is 30 mm. So over the dimension line we mentioned 30, and the axis height is 68 mm. Axis height is 68 mm. Over the dimensioning you just mention 68. Right. If you want, you just mention the note. Note needs to be mentioned, that is all dimensions are in mm. That should be mentioned right below. That's the right bottom of the drawing. All dimensions are in mm. Then scale 1:1. That is the true scale, right? So before you just even proceed to another drawing, you just check if anything is missed out. For that reason only, I always insist you to write down the checklist so that you can just cross check where and all the edges or the slant edges are connected. Hope you have all understood this. Thank you.